It's been a while since I've done a rant, but I want to go off of this because I came across this video this afternoon. This is a video from a YouTube channel. Doesn't matter at this point what it is, what channel this is from, but this is Arduino code that is often presented as test code, code that is sort of deemed to be quality code. Arduino is an environment that is marketed for young, early software engineers to give them a taste of software engineering. Yet we give them code that looks like this. And I have a lot of problem with this. But this code works. But it's using global variable states. It's doing logic statements like this that are very challenging to get right and understand. If you were to just been given this program, not told what it does, it would take a long time to sort of figure this out. This previous state, the loop coming in, global variables, it's so scattered that is incredibly hard to understand it. Yet this is the code that we sort of hold out as code that we want our early software engineering impressionable people to look at and start to write code that's going to be, we're going to pay them to do, and it's going to be put into production. So let me work on this. This is the same code that you saw before, just loaded in cursors. We can look at how it could be better. Now, hate these global variables. In the very least, you could do this, where you would store this as a local variable and these as stateful variables that you need to do. This would make this loads better rather than having a variable that could be local, be global, or in this fixed state, we make this as a local variable because it doesn't need to have global scope. However, like I mentioned, this statement is confusing. This right here is it pressed? And this is basically, has it changed? Like the last time around, was it not pressed, really? So like just this, but this doesn't read right. It doesn't read like it should be. So let me show you what I would want to have in place. The setup code, don't care. This is fine. One thing to note is that loop doesn't have to return. Loop can sit in a while loop, but we sort of almost traditionally let this return back to some sort of framework, and the magical framework simply calls loop again. So you need to know that. And it makes this, even just that, makes this so much better. So first thing I do is I write some helper functions. First, these two functions called button is pressed. So this is a Boolean return type of a function and returns true if the button is pressed. Oh, isn't that useful? Now we have an English statement for the mechanical thing that we want to be looking for. And similarly, the button is not pressed, kind of a convenience function, but this button is not pressed reads or will read a lot better than negating this or even saying that this is low. We have a function called wait for press. So we're going to sit here and we're going to wait while that button is not pressed. And so this is going to block until that button is pressed. Another really good convenient function. Similarly, we have its alternate ego for wait for it to release. So we're going to sit here and we're going to spin on this function until that button is not pressed or has been released. I'm going to actually show you this early. We're not going to use it in this first example, but you know what? Let's go past that and we'll go about it. We'll bring it up later. So in the first version of a better loop, we do this. One is we keep our current LED state on the stack, and we wait for the button to be pushed. Once it is pushed, we're going to toggle it, and then we're going to wait for the button to be released. And these delays are important to allow the button electrical signals to sort of stable out. It's a debounce. But we're just going to wait until it releases. So we have two states in a transition. This is going to sit here until the button is pushed. We transition. This is what we do. And this is we're going to block here until they release it. Infinitely more easy to read. If you were to look at this, even not knowing what wait for press does, you know exactly what this function is doing. We're going to wait until it presses. We flip it, and then we wait for it to release. Whew, easy to read. Not any less performant. This is, I'm going to call an even better loop. We have no state at all. We're storing our state on the stack. So we make sure that we start off with it being low. We wait for the button to be indicated that we want to change the state of the light. And we first go to high, and then we wait for a light change request to happen again. And then we go to low. This is even easier to read. We start low. We know what the starting state is. And we're going to toggle to high and low as we need to. So we have no variable state. We're just sitting here waiting. This is actually going to be the most performant version of this system. Not because we have variables. It is all on the call stack. So just to complete this wait for light change to request. Very simple. We have the make sure that the button is released little code here. So we're going to kind of do some debounce, make sure the electrical system's stable. We wait to make sure that that button is released. And then we, again, sort of do a electrical destabilization or stabilization of the signal. And then we wait for it to push, wait for it to be pressed. So this is a nice convenience function to say when this returns, there has been a request and it's immediate. So again, this is what I would want to see is here's the business logic of our application. And the rest of it is sort of just composed of these other functions that do very specific and obvious work. In the end, there's only one thing that's hitting our Arduino API, and that is the only specific thing about that. We could also have it would obviously make sense to say to have a set light to be that, and we would set the light to be high or low, and this would be set to low. So this is arguably a better way to write this. That way our only two functions that hit the API is this set light and button is pressed. Isn't that cool? Everything else is just logic off of that. So that's my little rant. Again, here's where we started from. It's correct. It probably took a little bit to get some of this logic right here. I won't argue that this is not correct and operational code, but I want to be able to teach our engineers, if they're using Arduino, this is how you ought to write code. Let's get them set up for success from the beginning.